let's double check that we all got the same thing for Mac and Tully's road trip. Okay, so they're going on a road trip from San Jose to LA. Those are both in California. And Mr. Mac is in the red Toyota. That's the red car. He started 50 miles from San Jose, and he's driving at an average speed of 30 miles per hour. So he's starting 50 miles away. Okay, and then each hour would be another 30 miles. He's going slow. So adding 30 miles each time. So hopefully your table for the red car, which I should have done in red, would look like that. For the blue car, Miss Tolley starts 10 miles from San Jose, and she has an average speed of 40 miles per hour, so adding 40 each time. You should have gotten add 40, that would be 330. Something like this for that one. Did I do it right? Hopefully our tables should look the same. So we made a data table. We can also plot the points. This time I will use red for the red car. So the red car started 50 miles away, and after an hour they were at 80 miles, and then they were at 110, then they were at 140, and then 170, and then 200, and then 230, and then 260, and then 290. So it makes this line, and we could actually connect it because they're driving constantly, so it's a continuous graph. You don't like drive every hour on the hour, and the rest of the time you just zoom to the next place. It'd be nice if you could, but that's not how it works. The blue car started at 10 miles away. After an hour, they were at 50 miles away, and then at 90 miles, and then at 130, and then at 170, 210, and then 250, and 290, and then 330 is off the graph. So could we write an equation for each of these cars? It says use M for miles and H for hours. So for the red car, the miles equal, so Y equals, so M equals, well, we could kind of do it one of two ways. You could write it as slope times X, which would be the hours, plus your y-intercept, if you want to think about it that way. Or, and this works a lot better for some of these word problems, what did we start with for the red car? Well, we started at 50 miles. And we're adding how much each hour? 30 miles each hour. For the blue car, we started 10 miles away. That's our starting point. And then we're adding 40 miles each hour. Who will get to LA first? Hopefully we wrote it down right. The one that gets to LA first is going to be the blue car. And who was driving the blue car? That was Tully. Tully. How do you know? Because the blue car gets there first. When will their cars be next to each other on the freeway? Well, that's when they're at the same location at the same time. So same location at the same time as there. So that's 4 hours away. And how far are they when they meet? Well, that is 170 miles. Could we use our equations to come up with that instead of the graph? Or even the table, that's when they're at the exact same spot. Let's see, it's on the table as well. That at 4 hours, they were both 170 miles away. Could we use the equations and not the table? Well, we'll get into that. We'll get to that into the notes. Okay, so the back side of this is our notes. The main concept today is that we are looking at the intro to systems of equations. A system of equations is two or more equations we solve at the same time. I'm writing too big, same time. The solution occurs when what? So let's think about how we determine the solution on that activity. The solution occurs when one x value gives the same y value. So remember, on that table, when the y values were the same, that meant we're at the same spot at the same time. So in a table, when we're solving a system, we try to find the x value that gives me the same y values at the same time. We're solving these at the same time. So here, which x value gives me the same y value for both equations? Well, here it is. When x is 3, doesn't matter which equation I look at, I'm getting a y value of 2. So the solution would be x equals 3, y equals 2. So we could write it two ways. We could actually write it as x equals 3, y equals 2. But that's also the point, 3, 2. Now let's look at the graph. We have two linear equations with two lines graphed. What x value makes them have the same y value? When are they at the same point at the same time? Well, that's actually when they intersect. So it's this point right here. And it looks like that's when at the point -4, 3. So now we can go back to the equation from the do now activity. How can we solve these equations? We want to know when they're at the exact same distance at the same time. So we want to know when their miles were equal, when the y values are equal. So the way we can set this up is we can take the red car. That was, I believe, well, let me make sure I grabbed the right one. The red car was the 50. When the red car, its miles equal the miles on the blue car. So what we can do is set those equations equal to each other. And then we could solve for that time, that hours, where they were at the same spot. So we're going to solve this just like we would any equation when we had variables on either side. We can either get all our variables on the left or all of our variables on the right. I think I'm going to get them all on the right side. So I'm going to subtract 30h from each side of the equation. And let's see what I have remaining on the left side. I still have a 50 over here equals 10 plus 10h. I would need to move that 10, so I'm going to subtract 10 from each side of the equation, and that gives me 40 equals 10 times h. So divide by 10, divide by 10, gives me a 1 over there. H equals 4. Now, notice that every solution has been an x and a y value. So it's the x that gives me the same y value for both things. So to find the y value that goes with this, or in this case, the miles, I would need to take that number and plug it in to one of the equations. Doesn't matter which one. I'll just pick the first one. I'll go with the red car. M equals 50 plus 30h. So that's M equals 50 plus 120. So the miles should be 170. Now, we should get the same answer if we plugged it into the other equation. Well, let's find out. M equals 10 plus 40 times the hours, so 40 times 4. M equals 10 plus 160, so the miles is 170. Cool. Awesome. The next one's a kind of a tricky one. This is going above and beyond. So we have our two equations. It's just, in this equation, we have fractions for our slope. No problem. We can still do this. So what we're going to do is, like we did here, we're going to set the equations equal to each other. In other words, since y equals this and y equals this, I can do a little substitution thingy, and I'm going to say that this means that 2/3 x minus 3 has to equal 1/4 x plus 2. Ooh, fractions. Now we could deal with them, but there is a neat little trick. If we multiply everything by the lowest common denominator, oh gosh, lowest common denominator. So lowest common denominator means that the denominator that both of these could divide into. So what number could both 3 and 4 divide evenly into? Well, that'd be a 12, wouldn't it? Okay, so I would need to, let's see what happens if I multiply both sides of the equation by 12. Craziness. So I'm going to multiply over here by 12, and I'm going to multiply this side of the equation by 12. I'm going to have to distribute so that I multiply everything by 12. 12 times 2 divided by 3. So 12 times 2/3. 12 times 2 is 24. Divided by 3 is going to give me 8. Test me. Check it in your calculator. 12 times 2 divided by 3. Then it gets distributed to the -3. So 12 times -3 is -36. 12 times 1/4. So 12 times 1 is 12, divided by 4 is 3. 12 divided by 4 is 3. Then 12 times 2, 12 times 2 is 24. Oh, that's neat. We have no more fractions now. Now it's just an easy equation. We need to get all the variables on one side, all the constants on the other. So let's see, I have 8x over here and 3x's over here. It'll be easier to take away 3x's from each side. 8x minus 3x is 5x. and then that's a 24. You get all the constants, the numbers on the other side, so I need to add 36, because the opposite of subtracting 36 is to add 36. So I get 5x equals, wouldn't that be 60? Divide by 5, divide by 5, we get x equals 12. Now we also have to find the y value that goes with this. So I can plug back into either equation to find the y. So I'm going to start with the first one. Y equals 2/3 x minus 3. So if we get in the calculator, 2/3 of 12, 2 times 12 is 24, divided by 3 is 8, minus 3 would be a 5. Let's see if we get the same thing if we plug into the other equation. 1/4 x, oops, y equals, plus 2. 1/4 x plus 2. 1/4 of 12 is 3, plus 2 is going to give me a 5. Cool. Same y value. That's awesome. So our solution over here is the x value and the y value that gives me the same for both. The same is 12, 5. That point is the same on both graphs. So I want you to take a few minutes and in your groups go ahead and do spend or save, and then we'll have, when everybody thinks they've gotten it, you can check the video to see if you got the right answer.